This episode will be a real technical deep dive again. So hold on tight and enjoy the ride. Do you know how atomic clocks work and why we need them for satellite navigation? My colleague Mattia will give you some insights.
My name is Mattia Reganaz. I'm a System Ground Operations Engineer here in DLR GfR. Part of my job is to take care and to monitor the activity of the atomic clocks that we have here in the German Control Center of Galileo. The PTF, the Precise Time Facility, is composed by 8 atomic clocks. 3 of them are active hydrogen masers and 3 of them are cesium clocks. Combining these clocks together, we are able to produce an error of maximum 1 second every 3 million years. But why are we using atomic clock? At the base of the signal transmission from the satellite to the end users, we have the speed of light. Speed of light is of about 300,000 kilometers per second. Translated into the speed of light, it's the distance that light travels in 0.000000001 seconds. So this is a very tiny amount of time. So we cannot use normal clocks to measure this amount of time, but to provide the necessary accuracy, we need to use atomic clocks. So atomic clocks measure the time by monitoring the natural frequency of atoms. For hydrogen, for example, this natural frequency is of 1.5 billion of oscillations per second. Okay, now imagine having a light bulb. At our home in Europe, the current is fluctuating at 50 Hertz. So our light bulb is actually pulsing 100 times every second, which is too fast for our eyes to be seen. But if we would be able to see this light pulsing, we could say that every time we see a pulse, 100th of a second has passed. And every time we count 100 pulses, the same for a whole second. So the same we are doing here in Galileo, but with something that pulses 15 million times faster than that light bulb, to measure something that is 50 million times smaller. Nevertheless, we still have to synchronize our Galileo system time to the more precise International Atomic Time, which by an error of 1 second every 3 million years, it's mind-blowing.
Thank you, Mattia, for taking us into the world of clocks. In 2 weeks, we will have a look which challenges we are facing by running a Galileo Control Center flawless. So stay tuned, and until then, keep reaching for the stars.